Now we have an example on rate of change. Given that b is the square root of x squared plus y squared plus z squared, we are asked to determine the rate of change of b given that x, y, and z increase at 0.6 centimeter per second, y increase at 0.5 centimeter per second, and z increase at 0.4 centimeter per second at this given coordinates. So let's write an expression of dB dt. Therefore, dB dt will be partial derivative of b with respect to x multiplied by dx dt plus partial derivative of b with respect to y multiplied by dy dt plus partial derivative of z of b with respect to z multiplied by dz dt. Now we understand that if they are increasing at this particular frequency or at the particular rate, then the x dt is 0.6 centimeter per second, the y dt is 0.5 centimeter per second, and dz dt is 0.4 centimeters per second. So the first thing to do is to evaluate dB dx. Evaluating dB partially with respect to x. Now b is equal to square root of x squared plus y squared plus z squared. And this, you can rewrite this in the form of x squared plus y squared plus z squared all raised to power half. Now this brings us back to function of a function. Okay, so we can say let u be equals to x squared plus y squared plus z squared. Since we are differentiating with respect to x, partially with respect to x, we can say du with the x partially, and we know that this will give us 2x, and after we have substituted this to be u, okay, therefore our b will now be equals to u raised to power half. Then we have to evaluate the b du. Remember, we are dealing with function of a function, and the b du is 1 over 2 u raised to power minus half. Therefore, partial derivative of b with respect to x will be the b du multiplied by du dx, and that is 1 over 2 u raised to power minus half multiplied by 2x, and this will give us x u raised to power minus half, and this is similar to x raised to power u divided by u raised to power half. So let us substitute our u back. So we are saying that the b dx is x divided by square root of x squared plus y squared plus z squared. In the same vein, we can say dB dy is y divided by square root of x squared plus y squared plus z squared, and dB dz is z divided by square root of x squared plus y squared plus z squared. Therefore, we can now go back to our expression of dz, of db dt, which is db dx multiplied by dx dt plus db dy multiplied by dx dy dt plus db dz multiplied by dz dt. And let's substitute our db dx, that's x divided by square root of x squared plus y squared plus z squared, and the x dt, as we have seen here, is 0.6 plus the b dy, that is y, divided by x squared plus y squared plus z squared, and dy dx dy dt, as we are seeing here, is 0.5. Sorry, excuse me. And db dz is z divided by square root of x squared plus y squared plus z squared multiplied by dz dt, which is 0.4. Now we can now rewrite this as 0.6x divided by square root of x squared plus y squared plus z squared plus 0.5y divided by square root of x squared plus y squared plus z squared, and 0.4z divided by square root of x squared plus y squared plus z squared. So when x, we give it that when x is equals to 5 centimeters, y is equals to 4 centimeters, and z is equals to 3 centimeters. After we will now make our substitution, we now have that this db dt is 0.8768 centimeters per second.